Imagine a moment so catastrophic, so overwhelming, that it rewrote the story of human civilization, reshaping our planet and erasing ancient societies in a matter of days. This is not a tale of mythology or unproven legends, but a real event, backed by the latest scientific discoveries in 2025. On this day, approximately 12,800 years ago, the skies unleashed a fury unlike anything mankind has witnessed before or since. The Earth experienced a sudden dramatic chill, a drop of around 15 degrees Celsius in mere weeks, abruptly bringing the last ice age to a deadly climax. Beneath this chilling veil, entire ecosystems collapsed, megafauna disappeared, and the civilizations that had begun to flourish vanished without a trace. The cause? A massive cosmic impact, an exploding comet bursting in Earth's atmosphere, showering the planet with fragments of unimaginable power and devastation. For over a century, scholars debated this event, known as the Younger Dryas, as an abrupt, cold snap marking the end of the last glacial period. But only recently, the year 2025, brought groundbreaking evidence from the depths of our oceans, ice cores, and archaeological sites around the globe, proving that this was not merely a climate anomaly, it was a cosmic catastrophe. Researchers uncovered platinum nanoparticles, a rare metal element often found in meteorites, embedded deep within ocean sediment layers dated precisely to this period. These tiny specks betray a moment when the heavens themselves rained down destruction. As the comet exploded high above the Earth's surface, it released energy equivalent to 10 million megatons of TNT, far surpassing any nuclear bomb ever detonated. The blast wave flattened vast forests, ignited wildfires that encircled entire continents, and sent shockwaves rippling across the planet's fragile ecosystems. The air burst vaporized everything in its path, scorching the land below, while the debris ejected into the atmosphere blocked sunlight for years, initiating a global winter so severe and prolonged that it devastated human survival and forced our ancestors into desperate adaptations. Surprisingly, and most intriguingly, this event was anticipated long before it happened. Deep in what is now Turkey stands the mysterious archaeological site of Göbekli Tepe, constructed shortly after the Younger Dryas. Here, intricate carvings etched onto massive stone pillars depict what scientists now interpret as astronomical records of a deadly comet shower. These pillars eerily mark the approach and fragmentation of a large cosmic body, a warning from those who lived through the devastation. It suggests that the survivors, the few humans who endured this apocalyptic period, sought to preserve knowledge, to prepare future generations for a repeat of this cosmic threat. This revelation challenges everything we thought about the dawn of civilization. It proposes that our ancestors were not merely helpless victims of nature, but skilled observers, scientists even, capable of predicting celestial dangers. Their monuments encoded warnings across millennia, meant to awaken us to the cyclic nature of these catastrophic events. Far from fairy tale, these stones are archives of cosmic history, laden with encoded prophecy and somber remembrance. The corruption we see in mainstream science, the stubborn denial of this impact hypothesis, only adds to the mystery. Ignored for decades, dismissed due to the absence of a traditional impact crater, the theory was relegated to the fringes. Yet recent discoveries challenge these doubts, unveiling a clearer picture of the airburst mechanics that shattered Earth without forming a crater, and exposing bias in scientific institutions resistant to rewriting established histories. The evidence now mounts relentlessly, coming from multiple continents, drilling deeply into ice cores from Greenland, examining sediment layers beneath the oceans, and analyzing radiocarbon dates aligning with catastrophic ecological turnover. What happened next is a tragedy mixed with hope. The comet's devastation annihilated the world as megafauna giants such as mammoths, giant sloths, and saber-toothed cats disappeared forever. Alongside these creatures, the sophisticated human cultures of the Clovis people were wiped out, their stone tool technologies and survival strategies lost in the flames. However, out of this ruin, humanity endured, carrying the seeds of recovery deep within their genes and memories. This extinction event caused a bottleneck in human genetics. Our entire global population shrunk to a few thousand survivors, ancestors of every person alive today. Their resilience carved the way for rebirth, the rise of agriculture, the first cities, pyramids, and the dawn of complex civilizations. But the echo of that cosmic blast remains, embedded not just beneath the earth, but in our DNA and cultural memory. Understanding this event is crucial not only to decode our past, but to prepare for a future that may hold similar dangers. As we look to the sky today, with telescopes scanning for near-Earth objects and meteor streams intensifying in their fury, one fact becomes undeniable. The cosmic cycle that brought disaster over 12 millennia ago continues to spin, and with it, the threat often hidden in the stars. This story, told here for the first time in such depth, blends the ancient mysteries carved in stone, the latest scientific breakthroughs of 2025, and the urgent warnings from deep time to our present moment. This is the forgotten day when the sky exploded and changed everything, our history, our future, and the fragile thread on which our civilization balances. As the fiery explosion faded from the sky and the ashes settled on the scorched earth, a remarkable tale unfolds at the heart of what is now southeastern Turkey. Just decades after this cosmic upheaval, survivors of this cataclysmic event established one of the most enigmatic and awe-inspiring sites known to humanity, Göbekli Tepe. This ancient sanctuary, built on a hilltop overlooking sweeping plains, defies conventional understanding of prehistoric human capabilities, revealing a civilization not only struggling for survival, but also possessed of extraordinary knowledge that challenges the narratives long held about our ancestors. Göbekli Tepe is far more than a ritual site. It is believed by leading archaeologists and astrophysicists to be an early observatory designed to record celestial events with astonishing precision, marking one of the earliest attempts by humans to comprehend and predict the cosmos. The massive T-shaped pillars, some weighing up to 20 tons, rise majestically in circles, adorned with intricately carved symbols, depictions of fierce animals, mythical beasts, and enigmatic patterns. Among these carvings, one stone stands out, the famous Vulture Stone, or Pillar 43, which astronomers have decoded as a celestial calendar that anchors humanity's most devastating event to the stars themselves. This pillar does not merely depict art. It functions as a sophisticated astronomical record, indicating the exact timing of the Younger Dryas impact event. The carvings align with the constellations known today as Sagittarius, Scorpius, Libra, Virgo, Gemini, and Pisces, marking crucial celestial positions as they appeared over 12,000 years ago. These constellations and symbols encode information about the precession of the Earth's axis, a complex astronomical cycle discovered officially only in 150 BCE by Hipparchus of ancient Greece. Yet here, carved deep into stone, lies proof that our ancestors not only observed but understood this cosmic phenomenon millennia before formal scientific documentation. Research published in 2024 and 2025, including ground-penetrating radar scans, revealed that Göbekli Tepe's construction phase dates back astonishingly close to the onset of the Younger Dryas event. This proximity suggests that the builders were a culture emerging in direct response to this disaster, commemorating what they perceived as the worst day in history. The symbolism of the pillar and its hermetic calendar reveal a message encoded intentionally, a warning and a remembrance, a desperate effort by these early humans to make sense of the devastating cosmic forces that shaped their world. Göbekli Tepe's location on a hilltop is not random but strategic. It likely served as an ancient observatory, affording uncompromised views of the heavens. Scholars have identified alignments that correspond closely with the position of pole stars in earlier millennia stars like Vega and Deneb, which served as important directional markers for the builders. The Site S enclosures are oriented precisely, showing a remarkable grasp of astronomy and geometry that implies not only sophisticated observation but also institutional knowledge and social organization. The precision with which these ancient peoples recorded these celestial events is staggering. The carvings on Pillar 43, for example, appear to encode specific dates, interpreting the positions of the sun during solstices and equinoxes, while also simulating the paths of distinct meteor streams. The recurring emphasis on certain star formations and symbols points to a deep awareness of periodic meteor showers, notably the Taurid meteor stream, an astronomical phenomenon responsible for intense meteor activity and strongly linked to the Younger Dryas impact hypothesis. This discovery suggests that those who lived through the catastrophe did not merely observe, it was a scientific endeavor, a calculated attempt to track cosmic rhythms to predict future dangers. This knowledge was passed down, etched in stone, as sacred lessons for generations to come. These early astronomers, carved into history, were not primitive. They were scholars, guardians of cosmic wisdom, and survivors who sought to prevent history from repeating itself. But the carvings at Göbekli Tepe do more than commemorate the past. They hint at a continuing cycle, a cosmic dance that threatens to return. The Taurid meteor stream, linked to the fragmentation of a giant comet, passes close to Earth every year, bringing increased meteor activity. Scientists today believe that approximately every 12,000 to 13,000 years, our planet passes through particularly dense regions of this debris field, a cycle that may explain not only the Younger Dryas impact, but other extinction events throughout Earth's history. Gobekli Tepe, therefore, is not just a monument to a catastrophe, it is a warning beacon, encoded in stone with a celestial calendar that urges vigilance. The site's mysterious symbols, filled with layered meanings and astronomical complexity, are echoes of a lost civilization's attempt to frame humanity's fragile existence within the vast and menacing cosmos. This profound legacy challenges us to reevaluate how we perceive ancient history, archaeology, and astronomy. No longer can we dismiss the prehistoric mind as simple or superstitious. Instead, we must recognize the foresight and observational skill that allowed these early humans to record the worst day in history with a precision rivaling modern science. They alert us that humanity's vulnerability to cosmic events is timeless and that understanding these ancient warnings could be key to surviving the next inevitable encounter. In connecting these ancient carvings with modern scientific inquiry, we bridge millennia linking the wisdom of a burned, beaten culture with the cutting-edge research of today's astrophysicists, geologists, and archaeologists. Göbekli Tepe stands as a testament to endurance, memory, and the unyielding human spirit to seek knowledge even in the darkest times. As you listen to this, reflect on the fact that while the comet exploded over 12,000 years ago, the sky and threat remains. The cosmic calendar at Gobekli Tepe foretells events tied not just to the past, but to an uncertain future waiting silently in the starry expanse above. The celestial warnings etched into the stones of Gobekli Tepe were not merely symbolic gestures or artistic expressions, they were urgent messages from a civilization that had witnessed the unthinkable. And more remarkably, they hint at a deeper mystery. If these ancient survivors possessed the astronomical knowledge to predict and document cosmic catastrophes, what other technological marvels might they have commanded before the sky exploded and erased their world? The answer lies buried beneath layers of ash, soot, and scorched earth, evidence of technologies so advanced, so unexpected, that modern science has struggled for decades to accept their existence. This is the story of what they left behind, the physical proof that challenges everything we thought we knew about prehistoric human capability. Across 4 continents, in locations separated by thousands of miles and vast oceans, archaeologists have discovered a mysterious layer in the geological record known as the Younger Dryas boundary, or YDB. This dark, carbon-rich stratum, dating precisely to 12,800 years ago, contains materials so exotic and unusual that they can only be explained by extraordinary heat and pressure conditions far beyond anything achievable through natural earthly processes or primitive human technology. Within this boundary layer, researchers have identified high-temperature iron silica spherules, microscopic balls of metal and glass that form only when temperatures exceed 2,200 degrees Celsius. To put this in perspective, modern industrial furnaces typically reach around 1,500 degrees, and even the most intense naturally occurring wildfires rarely surpass 1,000 degrees Celsius. The presence of these spherules indicates exposure to temperatures that would vaporize steel, melt rock, and instantly incinerate any organic matter. But the spherules are only the beginning. Scientists working at sites stretching from Syria to South Carolina, from the Channel Islands to the Atacama Desert, have unearthed nanodiamonds carbon crystals compressed at such extreme pressures that they can form only during massive explosions or asteroid impacts. These nanodiamonds, scattered across continents in a synchronous layer, tell a story of unimaginable violence visited upon the Earth. Alongside them lie Lonsdaleite crystals, a hexagonal form of diamond even rarer than traditional cubic diamonds, known to form exclusively during hypervelocity impacts when meteoritic material slams into terrestrial surfaces at speeds exceeding 15 kilometers per second. The presence of these materials across such widespread geographical locations cannot be explained by volcanic activity, lightning strikes, or human activity. They are the unmistakable signatures of cosmic collision. Perhaps most intriguing among the technological remnants is the discovery of melt-glass silica-based rock that has been heated to such extreme temperatures that it liquefied and then rapidly cooled into glassy formations. At Abu Huraira, an archaeological site in northern Syria that was inhabited during the transition from hunter-gatherer societies to early agriculture, researchers found chunks of this melt glass embedded within the Younger Dryas boundary layer. Chemical analysis revealed that this glass contains melted building materials, including fragments of mud brick and limestone, mixed with partially vaporized plant matter and bone. The temperatures required to create such fusion exceed anything that could be produced by conventional fires or even advanced metallurgical processes. The only plausible explanation is an airburst, a cosmic impactor, exploding in the atmosphere with such ferocity that the radiant heat alone melted everything in its path. What makes the Abu Huraira discovery particularly significant is the context in which this melt glass was found. The settlement was home to one of humanity's earliest experiments with agriculture, where ancient peoples first began cultivating wild grains and transitioning from nomadic lifestyles to settled communities. The sudden destruction preserved in the geological record suggests that this budding civilization, on the cusp of a transformative leap forward, was abruptly interrupted by cosmic catastrophe. The charred remains, the vitrified materials, and the abrupt cessation of habitation all point to a moment of apocalyptic violence, a moment when the sky itself became a weapon. The technological sophistication suggested by these materials extends beyond mere survival tools. At sites across North America, archaeologists have documented the disappearance of Clovis culture, a sophisticated society known for their distinctive, beautifully crafted spear points that represent some of the finest stone tool technology ever developed. These fluted projectile points, masterfully knapped from high-quality stone, required exceptional skill and knowledge of material properties to create. Clovis hunters wielded these tools to bring down megafauna like mammoths and mastodons, animals that stood over 13 feet tall and weighed several tons. The sudden vanishing of Clovis artifacts from the archaeological record coincides exactly with the Younger Dryas boundary, suggesting that whatever technological and cultural knowledge they possessed was lost in the catastrophe. But the loss was not merely of stone tools, it was the erasure of accumulated knowledge, the destruction of social networks, the collapse of trade routes, and the obliteration of oral traditions that had been passed down for generations. Some researchers have proposed that the pre-impact cultures possessed not just advanced stoneworking techniques, but also sophisticated astronomical observations, navigation skills, and perhaps even early forms of writing or symbolic notation that have been lost forever. The sudden disappearance of these capabilities forced the survivors into a technological dark age, from which humanity would take millennia to recover. Among the most compelling pieces of evidence are the elevated concentrations of rare elements found within the YDB layer. Platinum group metals, including platinum, iridium, osmium, and ruthenium, appear in anomalously high concentrations precisely at this boundary. These elements are exceedingly rare in Earth's crust, but abundant in asteroids and comets. The discovery of platinum spikes in ocean sediment cores, announced in August 2025 by researchers at the University of South Carolina, provided some of the most convincing evidence yet for extraterrestrial impact. These platinum nanoparticles, distributed globally in a thin layer corresponding exactly to the onset of the Younger Dryas, represent the fallout from a cosmic collision, microscopic fragments of the impactor itself, scattered across the planet like cosmic confetti. The technology to detect these platinum nanoparticles, measured in parts per billion, has only recently become available. Advanced mass spectrometry and electron microscopy techniques have allowed scientists to identify materials that would have been invisible to earlier generations of researchers. This technological advancement explains why evidence for the Younger Dryas impact has mounted so dramatically in recent years, not because the evidence is new, but because we finally possess the tools to see it. This revelation underscores a humbling truth. The limitations of our technology can blind us to truths that have been literally under our feet for millennia. The shocked quartz discovered at multiple Younger Dryas sites provides yet another smoking gun. When examined under microscopes, these quartz grains display distinctive planar deformation features, parallel fractures filled with glass that form only under the extreme shock pressures generated by hypervelocity impacts or nuclear explosions. These microscopic scars tell a story of violence measured in microseconds, of shock waves traveling faster than sound, of pressures that momentarily exceeded those found at the bottom of Earth's deepest oceans. The presence of shocked quartz at sites thousands of miles apart, all dated to the same narrow time window, eliminates any possibility of localized causes and points unequivocally to a global event. What emerges from this accumulated evidence is a picture of a lost world, a world where human societies had developed technologies and knowledge systems more sophisticated than previously imagined. A world poised on the brink of transformation. The survivors of this catastrophe, scattered and traumatized, carried fragments of this knowledge with them as they migrated, adapted, and slowly rebuilt. They encoded their warnings in stone. They observed the heavens with the wariness of those who had seen the sky turn against them, and they passed down stories that would eventually become the flood myths and catastrophe legends found in cultures around the world. The technology they left behind in the form of exotic materials, advanced tools, and astronomical monuments serves as a testament to what was lost and a warning of what could happen again. The profound technological insights and devastating cosmic events we've explored lead naturally to one undeniable truth. These ancient societies were confronted not only by disaster, but also by profound environmental change. The world they knew was shifting beneath their feet, oceans rising, landscapes drowning, and entire regions becoming unrecognizable. This brings us to an extraordinary chapter in human history, the drowned cities and submerged civilizations, remnants of a time when rising seas permanently altered the course of civilization. As the fiery comet ashes settled, the Younger Dryas cold period that followed brought a sudden and dramatic alteration in climate. Glaciers, which had dominated vast land masses for thousands of years, began to retreat abruptly. This rapid melting unleashed colossal volumes of fresh water into the oceans, raising sea levels in a matter of centuries by an estimated 120 meters. Coastal regions worldwide that had been home to thriving early human communities were swallowed by the encroaching waters. What had been fertile river valleys and bustling settlements slowly transformed into underwater ruins, hidden beneath the waves, their stories lost to time and tide. Archaeological discoveries in recent decades have lent powerful support to this catastrophic flooding hypothesis. Sites around the world, from the coastlines of the Mediterranean and the Black Sea to the islands of the Pacific, bear mysterious signs of past inundation. Ancient shorelines, now submerged, reveal relics of human habitation tools, foundations, and sometimes even entire city layouts preserved beneath layers of sediment. These discoveries dovetail strikingly with the persistent motifs of flood myths found in the folklore and religious texts of innumerable cultures. From the biblical tale of Noah to the Mesopotamian epic of Gilgamesh, from the Hindu story of Manu to Native American and Aboriginal Australian legends, the motif of a great world-changing flood recurs with remarkable consistency. These flood myths, often dismissed as mere allegory or superstition, now demand a re-evaluation through the lens of scientific discovery. Carbon dating and sediment analyses reveal that many of these narratives likely stem from memories of real catastrophic flooding events occurring around the same historical time frame, the end of the Younger Dryas. For instance, the Black Sea, a critical nexus for ancient human activity, underwent a massive and rapid flooding event roughly 7,600 years ago, turning what was once a freshwater lake into a vast saltwater sea. The dramatic transformation of this region would have left an indelible mark on the cultures around its shores, sowing the seeds for flood stories that resonate through time. The physical evidence supporting these submerged civilizations is compelling. Off the coast of Turkey, researchers have identified what could be the remains of once thriving settlements, now resting beneath the waves. Along the coasts of Japan and in the islands of the Caribbean, submerged structures dating back thousands of years hint at human habitation lost to rising seas. In the Americas, sites such as the Bimini Road in the Bahamas have captured the imagination of explorers and scientists alike, suggesting the existence of ancient engineered structures hidden beneath shallow waters. But the story extends beyond just the loss of physical places. The rapid flooding would have dismantled food sources, disrupted migration patterns, and fractured social networks. As coastal communities faced displacement, they pushed inward and upward, spreading rapidly across new territories. This upheaval likely spurred significant cultural transformations, including the shift from nomadic hunter-gatherers to more settled agricultural societies. In the Fertile Crescent and other cradle regions, these migrations and environmental pressures may have catalyzed the accelerated development of farming techniques, social stratification, and eventually urbanization. The inundation of these ancient communities also explains the sudden appearance of advanced civilizations elsewhere, seemingly emerging out of nowhere. The rise of early Bronze Age cities in Mesopotamia, Egypt, and the Indus Valley can be seen as part of a post-cataclysmic continuation or rebirth. Survivors carrying precious knowledge of astronomy, metallurgy, and engineering resettled in these new heartlands, reconstructing societal frameworks while fading into legend. The flooding helped conceal the true depth and complexity of these earlier cultures from the historical record, creating gaps and mysteries that scholars still puzzle over and media often sensationalize. This narrative of drowned cities was at the core of the ancient legend of Atlantis, immortalized by Plato, who described the civilization as lost beneath the sea due to divine punishment or natural disaster. Strikingly, his timeline for Atlantis' demise roughly coincides with the end of the Younger Dryas, suggesting that this story, too, may have roots in historical events. Modern research connects this myth to real geological phenomena, with underwater surveys revealing possible archaeological features near locations like the Azores and the coasts of Western Europe. stirring debate over whether Atlantis was fact, myth, or a blend of both. The importance of understanding this drowned world extends to present and future concerns. With ongoing climate change, rising sea levels threaten modern coastal cities, many of which sit atop millennia of accumulated human history. Much like the ancient civilizations lost to the Younger Dryas melt, our modern societies face the risk of sudden displacement and widespread disruption. The drowned cities of the past serve as a somber reminder of nature, as power, and humanity's enduring struggle to adapt and survive in the face of overwhelming environmental change. Scientific endeavors today strive not only to uncover these submerged legacies, but also to learn from them. Advances in sonar mapping, underwater archaeology, and sediment dating allow exploration of sites previously inaccessible. As more discoveries come to light, the picture of human history grows ever more complex and interconnected. The evidence confirms that the Younger Dryas event was a watershed moment, not just in climate history, but in the human saga itself, forcing migrations, innovations, and a redefinition of humanity's relationship to the natural world. This chapter of history challenges us to broaden our perspective, to see ancient stories not as distant fables, but as encoded memories of real events, grounded in geological and archaeological reality, to appreciate the ancestors' resilience in confronting devastating floods, rising waters, and environmental upheaval. Their struggles and adaptations form the foundation of civilization. Continuing evolution, a story written as much in water and stone as in fire and stars. Following the profound tale of rising waters that swallowed entire coastal settlements and rewritten the geography of human civilization, we descend deeper into a story entwined with mystery, mythology, and the faint echoes of lost greatness. The evidence unearthed from submerged ruins and vast sediment layers around the globe inevitably leads us to one of the most enduring legends in human history, a tale of a magnificent civilization swallowed by the sea, its secrets buried beneath waves and whispers. This is the story of Atlantis, or rather, the reality behind the myth, seen through the lens of the Younger Dryas cataclysm and emerging scientific revelations from 2025. The myth of Atlantis, first chronicled by the ancient Greek philosopher Plato, has captivated imaginations for millennia. Plato paints a picture of a vast, advanced island nation existing around 9600 BCE, an era that strikingly aligns with the timeline of the catastrophic environmental shifts and cosmic impact events surrounding the Younger Dryas period. According to Plato's accounts in Timaeus and Critias, Atlantis was a utopian civilization, a naval powerhouse with sprawling cities, intricate waterways, and monumental architecture rivaling anything ancient or modern. It was said to possess unparalleled technological and cultural sophistication, governing much of the Western world before sinking beneath the waves in a single day and night of catastrophic flooding and earthquakes. The stunning parallels between this legendary account and scientific data have fueled serious inquiry over recent decades. Oceanographers, geologists, and archaeologists began to find submerged ancient structures, possible urban layouts hidden beneath shallow seas and continental shelves. Underwater surveys off the coast of places such as the Azores, the Bahamas, most famously the Bimini Road, and parts of the Mediterranean reveal linear and geometric formations that resemble ancient roadways, walls, and platforms. While definitive proof remains elusive, these findings hint at the existence of grand human constructions lost to sea level rise and natural disasters following the Younger Dryas impact. More compelling, however, is the growing body of evidence connecting this destruction to the rapid flooding and ecological shifts caused by melting ice sheets and massive comet fragments exploding in the atmosphere. The Younger Dryas impact hypothesis posits that the cosmic collision triggered a series of environmental catastrophes, including wildfires, climate upheaval, and the rapid melting of vast glacial sheets. This sudden influx of fresh water into the oceans elevated sea levels and caused natural disasters on a scale sufficient to obliterate any coastal civilization. Recent studies also note a correlation between the timelines of mythological flood legends across the globe and the Younger Dryas period. Tales of great deluges emerge not only in Western traditions, but in cultures across Asia, Africa, and the Americas, suggesting that these narratives might be collective memories of a shared ancient trauma. Interestingly, some folklorists propose that some stories, in their retelling and regional adaptation, preserve faint recollections of Atlantis or its analog societies lost to waters and buried in time. Scientific endeavor has turned dramaturgical myths into testable hypotheses. Ice cores from Greenland and Antarctic, sediment cores from ocean floors, and stalagmite samples from caves show abrupt climate shifts consistent with the theory of rapid environmental change. They also reveal sudden spikes of rare metals and other markers of cosmic impact material. This tantalizing intersection of myth and science opens doors to reinterpreting our understanding of prehistory not as fragmented, isolated tales, but as a connected human story of survival, loss, and adaptation. Meanwhile, in the Pacific Ocean, the sunken continent of Mu, once heralded as a mythical precursor to modern civilizations, enters discussions because of similar timelines and legends of disappearances tied to massive earthquakes, fire, and floods. Like Atlantis, Mu was said to have been a vast landmass supporting advanced cultures, lost beneath the waves and preserved only in oral traditions and scattered archaeological hints. While concrete evidence remains elusive here, the convergence of these stories around the Younger Dryas epoch cannot be dismissed as mere coincidence. What's remarkable is the evolving scientific consensus that links these diverse pieces: submerged architecture, climate data, archaeological layers, and ancient mythology to a window of time marked by upheaval and renewal. Far from being unrelated or mythological exaggerations, Atlantis and similar legends may represent human attempts to memorialize lost homelands, teach disaster preparedness through oral tradition, and maintain cultural identity despite trauma. Intriguingly, the legend of Atlantis also carries a cautionary tone, an admonition against hubris, environmental misuse, and unchecked technological ambition. Plato's dialogues suggest that it was not just natural forces, but the failings of great societies that led to ruin. This message resonates profoundly today, as current ecological challenges remind us of the fragility of civilization and the potential consequences of ignoring warnings etched in both stone and story. In addition to submerged ruins and mythic echoes, other fascinating discoveries from the Younger Dryas period hint at the survival and transformation of knowledge. For instance, some researchers propose the migration of survivors carrying precious astronomical, architectural, and engineering knowledge to safer grounds where this ancient wisdom was woven into new societies. These migrations increased cultural interconnectedness, leading to the rapid emergence of early cities with pyramids and temples weaving the legacies of lost civilizations into the fabric of emerging ones. The story of Atlantis, therefore, is more than a myth. It's a call to understand the cycles of destruction and rebirth that shape human destiny. It challenges us to combine science with tradition, archaeology with storytelling, in order to reconstruct a fuller, richer history of our species. The interplay of cosmic events, climate change, technological prowess, and human resilience forms the core of an epic saga, one that continues to unfold as new discoveries surface from beneath the waters, from dug-up ruins, and from the pages of our shared cultural memory. From the echoes of lost civilizations and oceanic depths, we now turn our attention to the survivors, those who endured the fiery wrath and rising tides, carrying the seeds of human continuity through the darkest of times. These were not mere remnants of a shattered past. They were bearers of knowledge, memory, and resurgent hope. The survivors of the Younger Dryas impact and flood event did not simply vanish into obscurity. Instead, their movements, adaptations, and transmissions of knowledge paved the road toward the dawn of civilizations, from the enigmatic temples of ancient Egypt to the fertile fields of Mesopotamia and the mysterious cities of the Indus Valley. Recent scientific studies have begun illuminating the paths these survivors may have taken. Ice core data from Greenland reveals an initial spike in platinum and rare cosmic materials coincident with the impact, followed by a decades-long climatic cooling. Yet intriguingly, there is evidence suggesting some level of human resilience or persistence through this dark epoch. Genetic analyses point to a significant but narrow bottleneck in the human population around 12,800 years ago, an event that reduced global human numbers to only a few thousand, a near extinction. This bottleneck signature in our DNA is a stark reminder of the impact's severity, but also a testament to the endurance of those who carried humanity forward. These survivors were not passive. As the glaciers receded and the climate slowly warmed, they began to repopulate safer areas, moving away from flooded coasts and devastated landscapes into new territories. Archaeological sites such as Göbekli Tepe, already discussed as cosmic observatories and warning centers, mark early steps in the post-impact era, a new chapter of human innovation and social organization. Far from being endpoints, these sites are beginnings, where knowledge, culture, and spiritual understanding coalesced into something that would eventually become civilization, as we understand it. One of the most fascinating enigmas surrounding these survivors is their sudden burst of knowledge and advancement, particularly in astronomy, mathematics, and architecture. Although conventional views have long held that complex societies and monumental architecture arose gradually over millennia, evidence suggests a much faster cultural renaissance after the Younger Dryas. Temples, pyramids, and urban centers appeared with architectures aligned precisely with celestial events, an echo of the cosmic observatories at Gobekli Tepe. The meticulous planning behind these structures implies not just survival, but intention, a desire to reconnect humanity with the rhythms of the cosmos and immemorial wisdom of ancestors. This rapid cultural acceleration reflects a possible transmission of knowledge from the earlier lost civilizations, passed on through oral traditions, symbols, and migrating peoples. Survivors likely carried stories of catastrophe and renewal, embedding warnings and teachings about cosmic threats into myths, rituals, and emerging religions. These narratives, from flood myths to the tales of gods and skies, encoded collective memory and practical knowledge, guiding societies grappling with an uncertain and volatile environment. The geographic spread of these post-impact centers provides clues to the movement of survivor populations. Sites in the Fertile Crescent, such as Jericho and Catalhoyuk, show signs of early urban settlement and agricultural experimentation dating to just after the Younger Dryas. In Egypt, the proto-dynastic period saw the genesis of complex state formation, with megastructures like the Step Pyramid of Djoser embodying engineering feats previously thought impossible for that era. Similarly, the Indus Valley civilizations emerged with remarkable sophistication in town planning, water management, and trade networks. Archaeological coffins, burial practices, and religious iconography from these periods reflect growing societal complexity and spiritual expression. They also hint at a shared cosmology influenced by a profound awareness of cycles of seasons, stars, and the re-emergence of life after catastrophe. The alignment of temples and cities with solstices and equinoxes echoes the ancient observatories at Gobekli Tepe, as if humanity sought to re-establish itself by harmonizing with universal rhythms. These developments also suggest a cautionary undertone, the implicit understanding that while life had returned, it remained vulnerable. The knowledge of cosmic cycles and their destructive potential may have informed early calendars and astrological traditions, embedding a persistent warning within the culture's foundation. This knowledge was vital. As history shows, Earth's celestial environment is dynamic, and humanity's safety depends on understanding those cycles. Genetic evidence further supports this narrative. Studies of mitochondrial DNA and Y chromosomes reveal patterns consistent with a dramatic bottleneck and subsequent expansion of human populations after the Younger Dryas. Such genetic maps also trace migrations into Europe, Asia, and the Americas, suggesting a diaspora of survivors who carried with them both the biological legacy and cultural knowledge necessary for rebuilding. Moreover, climate models indicate that the climatic upheaval triggered by the impact may have been a catalyst for the Neolithic Revolution, the shift from nomadic hunting-gathering to settled farming societies. The environmental instability may have forced humans to innovate new survival strategies, such as crop cultivation and animal domestication, inaugurating the agricultural age. This transition fundamentally altered human society, setting the stage for technological advancements, population growth, and the eventual rise of cities. In essence, the survivors of this cosmic catastrophe were the architects of a new world order, drawing lessons from devastation to craft a future resilient to disaster. Their legacy is etched not only in ruins, but embedded within our very genetics and cultural memory. Understanding their journey provides invaluable insight into human adaptability and the interplay between cosmic forces and civilization. As the dust of ancient catastrophes settled, humanity began to rebuild, but the cosmic rhythms that brought destruction so long ago did not cease. In fact, they continue to echo across the vast reaches of time, reminding us that the sky remains a realm of both wonder and peril. This brings us to a crucial chapter in our story, the warning signs that persist today. The subtle yet ominous signals that the celestial cycle which once nearly ended human civilization is still very much active and possibly accelerating. Modern astronomy and space science have entered an era where we can monitor near-Earth objects, NEOs, with unprecedented precision. Telescopes, satellites, and radar arrays scan the skies constantly, searching for asteroids and comets that pose potential threats. Yet, despite these advances, the deeper cosmic cycles, those spanning millennia, are less understood, and their implications perhaps underestimated. The Younger Dryas event, which unfolded nearly 13,000 years ago, appears to be part of a repeating pattern tied to the passage of the Earth through dense regions of debris left by long disintegrated comets. One such debris stream, known as the Taurid meteor stream, is particularly notable. Responsible for annual meteor showers observed around late October and early November, the Taurids are composed of fragments from a giant comet that broke apart thousands of years ago. This stream crosses Earth's orbit every year, but these fragments are now understood not to be uniformly distributed. Scholarly research and observational data suggest that the Earth could periodically encounter concentrated swarms within this stream, which dramatically increases the risk of atmospheric explosions or impacts. Indeed, scientists have found evidence that vast concentrations of these cometary remnants, some as large as several stories tall, pass perilously close to Earth, separated by gaps of roughly 12,000 to 13,000 years, remarkably matching the timeline of the Younger Dryas event. This cyclical pattern is corroborated by geological evidence of multiple sudden climate shifts and extinction events throughout Earth's history. As such, the cosmic threat that pummeled Earth in the late Pleistocene may not have been a one-off tragedy, but the most recent dramatic entry in an ongoing celestial dance. Compounding this long-term cycle is the recent increase in observed near-Earth objects. In 2023 and 2024, astronomers tracked an unusual rise in the frequency and intensity of meteor activity associated with the Taurid stream. Several near-miss asteroid space rocks passing closer to our planet than the Moon were observed, including objects that, had they struck, would have released energy comparable to large nuclear weapons, capable of causing regional or global devastation. NASA and international space agencies are actively monitoring this increased activity with new space-based telescopes and tracking systems designed to identify and catalog hazardous objects early enough to mount deflection or evacuation efforts. However, the sheer number of these debris fragments poses a daunting challenge. Many smaller but still dangerous objects evade early detection due to their size, speed, and unpredictable trajectories. As Earthlings, we live under an invisible shield of vigilance, aware but not immune to cosmic hazards. The warning signs extend beyond the mere tracking of objects in space. Earth itself displays signs of increased exposure to debris impacts in the form of anomalous atmospheric phenomena, unexplained fireball sightings, and localized airburst explosions detected over recent years. These events serve as grim reminders that even small fragments of cometary debris carry the potential to disrupt daily life profoundly. By connecting these contemporary observations with ancient warnings encoded in sites like Göbekli Tepe and the flood myths passed down through generations, a pattern emerges. Our ancestors understood this risk intimately, embedding it in their calendars, myths, and monuments as a constant caution. While modern technology enhances our ability to see threats in space, the lessons of deep history remind us that vigilance must be sustained across centuries, if not millennia. The personal stakes of these warnings are enormous. Unlike the distant past, today, a global civilization relies heavily on interconnected infrastructure, satellite technology, and dense population centers vulnerable to disruption. The impacts of an unexpected large meteor or comet explosion within the atmosphere could cripple power grids, satellite communications, and supply chains within minutes. Emergency preparedness on such a scale demands not only technological readiness, but also worldwide cooperation and awareness, a challenge for even the most advanced nations. Further compounding the urgency is the realization that our monitoring capabilities, while advanced, are not infallible. Smaller celestial bodies, just tens of meters in diameter, still capable of causing massive regional destruction, can be difficult to detect against the glare of the sun or obscured by space debris. The dynamic nature of cometary debris fields means that new threats can arise unexpectedly, requiring continuous enhancement of detection and deflection strategies. Scientific communities worldwide are collaborating to model the trajectories of known debris streams and potential impact probabilities over coming decades and centuries. These models inform the design of missions to test asteroid deflection technologies such as kinetic impactors and gravity tractors, while planetary defense councils work on coordinated response plans. Public education campaigns emphasize the importance of understanding cosmic hazards as an intrinsic element of risk management for future generations. The skies of today whisper a message rooted in deep time and ancient experience, a message meticulously preserved in stone, myth, and now science. It speaks of a cycle of destruction and renewal, of humanity's precarious place in a vast and often hostile cosmos. It warns us that the deception of safety is a fragile illusion, one that must be shattered to build resilience. The celestial dance continues, sweeping across cosmic timescales and intersecting fatefully with the trajectory of human history. Our story now shifts to the mounting evidence details and discoveries in recent years that confirm the cyclical nature of this cosmic threat and deepen our understanding of the patterns that nearly ended civilizations long ago. The lessons of the past have never been more relevant as humanity faces a sky alive with fire and motion. Among the most compelling contemporary concerns is the Taurid meteor stream, a celestial sojourn born from the disintegration of Comet Encke, an ancient wanderer that has left a trail of debris spanning millions of miles across our solar system. This debris stream manifests each year as brilliant meteor showers gracing the sky in late October and early November. Yet, beneath the beauty of these Halloween fireballs, scientists have uncovered a far graver reality, a heightened risk of hazardous near-Earth objects within this stream, capable of inflicting catastrophic damage similar to the Younger Dryas impact. This realization comes from recent research culminating in 2025, led by planetary scientist Dr. Mark Boslow. His team's findings, presented at the Planetary Defense Conference in Cape Town and published in Acta Astronautica, highlight the existence of what they term the Taurid resonant swarm, a dense concentration of meteoroids clustered and shaped by Jupiter-esque gravitational resonance. This group may periodically pass particularly close to Earth, significantly increasing the risk of airburst events and surface impacts like the one that shaped ancient history. The research emphasizes two forthcoming potential encounters in 2032 and 2036, when Earth's orbit may intersect this denser region of the Taurid stream. While smaller meteoroids harmlessly ignite as shooting stars, this swarm could harbor objects ranging from the size of houses to mountain boulders, capable of unleashing explosive energy, rivaling large nuclear devices upon entering our atmosphere. These objects may not necessarily create large impact craters, but can detonate explosively, releasing destructive shockwaves and fires similar to the 1908 Tunguska event in Siberia, which flattened over 2,000 square kilometers of forest without leaving a crater. This research underscores a disturbing truth. While current planetary defense systems monitor thousands of near-Earth objects, many small to medium-sized meteoroids remain undetected due to their size, trajectory, or the sun's glare. The hypothetical swarm is elusive, blending into the background of the solar system as chaotic debris, but its potential for harm is undeniable. Advanced telescopes and radar systems in 2032 and 2036 might finally detect these objects with sufficient warning. But until then, humanity lives precariously unaware. In addition to identifying this resonant swarm, scientists have noted unusual increases in natural fireball and airburst observations consistent with Taurid debris signatures in recent years. In the 1970s, seismic activity detected on the lunar surface correlated with this stream, while Earth has experienced sporadic, unexplained fireball events, causing localized panic and damage. Each fiery visitor from space serves as a reminder that our planet's cosmic environment remains turbulent, far from tranquil. Intriguingly, the patterns observed in ancient impact events, such as the Younger Dryas, echo through contemporary risk assessments, reinforcing a worldview where cosmic collisions are recurrent, cyclical, and for all practical purposes inevitable. The knowledge that resonant swarms are modulated by giant planets like Jupiter, a celestial shepherd influencing debris paths, and clustering offers a predictive framework that ancient civilizations, in their stone calendars and cosmic art, may have intuited through observation. This cyclical threat highlights a fundamental paradox. Earth's position in the solar system exposes it to cometary debris streams that bring both beauty and destruction. Meteor showers inspire wonder, yet they are harbingers of potential apocalypse. Understanding and anticipating the arrival of dangerous clusters within these streams is thus a paramount goal for planetary defense. The personal stakes of this cosmic hazard are enormous. Today's global society, tied together by fragile technological networks, supercharged economies, and colossal urban centers, is vastly more vulnerable to sudden disruptions than our ancestors. A single sizable airburst over a major city could knock out power grids, disrupt telecommunications, and trigger widespread panic. In a hyper-connected world, the cascading effects could ripple far beyond the immediate impact zone, challenging emergency services, food supply chains, and political stability. Governmental agencies and international coalitions are now prioritizing planetary defense, allocating funds and scientific resources to scanning the skies, developing asteroid deflection capabilities, and refining impact mitigation plans. Yet, political and public awareness struggles to keep pace with scientific uncertainty, often hampered by the complexities of communicating probabilistic risks and the seeming remoteness of cosmic threats. This gulf between knowledge and action constitutes an ongoing challenge for humanity's preparedness. Our ancestors, keen observers of the skies and architects of ancient knowledge, encoded warnings not only about past events, but also about future cosmic cycles. From Gobekli Tepe's stone pillars to flood myths and celestial calendars, these legacies form a bridge linking the distant past with current scientific inquiry, emphasizing an urgent continuity of vigilance. We are thus custodians of a millennia-old message, charged with deciphering and acting upon it. Scientific research into torrid resonant swarms and associated near-Earth objects continues, with telescopic sky surveys and space missions planned to clarify the scale and nature of these threats. Success in these endeavors holds the promise of transforming planetary defense from a reactive to a proactive stance, potentially one day enabling humanity to deflect or disrupt a threatening object long before it nears Earth. In this delicate balance between cosmic probabilities and human survival lies our shared destiny. The evidence of 2024 and 2025, supported by groundbreaking observations, invites a profound reckoning that we must view our place not as masters of a safe planet, but as sentinels watching a turbulent sky, armed with the wisdom of ages and the tools of modern science. Despite the growing cachet of scientific evidence pointing towards a cosmic event that reshaped human history nearly 13,000 years ago, the Younger Dryas impact hypothesis has long been met with skepticism, controversy, and resistance within parts of the scientific community. This resistance is not uncommon when revolutionary ideas challenge long-standing paradigms, but it has contributed to delays in acceptance and funding for research that could deepen our understanding of this pivotal moment. To fully appreciate the magnitude of what has been uncovered and what remains to be explored, we must journey through the scientific discourse surrounding this dramatic theory. The initial dismissal of the impact hypothesis rested largely on the absence of a definitive impact crater, a hallmark of most extraterrestrial collisions. Critics argued that without such a crater, the theory was untenable, suggesting instead alternative causes for the abrupt climate shift, such as volcanic activity or gradual climatic fluctuations. Volcanic eruptions, particularly the Lacher See volcano in Germany, were cited as plausible drivers of the Younger Dryas cooling due to their potential environmental and atmospheric impacts. The absence of a globally consistent layer of volcanic ash comparable to the Younger Dryas boundary (YDB) layer further clouded this explanation. However, recent research clarifies this apparent paradox. The Younger Dryas impact appears to have taken the form of a massive airburst, an explosion of a comet or asteroid at high altitude before impacting the surface rather than a classic impact forming a crater. This type of event can unleash energy equivalent to millions of atomic bombs, producing widespread devastation without necessarily leaving a traditional impact crater. The 1908 Tunguska event in Siberia is a modern example, leveling thousands of square kilometers of forest, yet creating no identifiable crater. This revelation aligns with the missing crater puzzle and underscores the scale and nature of the Younger Dryas event. Adding further complexity to the debate are disparities in geological and archaeological records across regions. While YDB markers and impact proxies like shocked quartz, nanodiamonds, and platinum spikes have been found on multiple continents, some researchers have struggled to replicate findings or interpret them differently. Variability in sedimentary deposition, contamination, and dating precision complicates the uniformity of evidence, encouraging a cautious approach. Nonetheless, the cumulative global distribution of these markers increasingly supports a synchronous, catastrophic event. Moreover, the Younger Dryas impact hypothesis challenges other established narratives, including those related to human cultural evolution. Some archaeologists resist reinterpreting known archaeological transitions, such as the disappearance of Clovis culture or abrupt shifts to agriculture, as consequences of cosmic causes, preferring explanations anchored in human innovation or localized environmental changes. This paradigm friction fuels ongoing debates about how best to interpret the archaeological record in the context of potential extraterrestrial influences. Despite these controversies, the weight of new evidence has prompted a gradual shift in scientific perspectives. Peer-reviewed studies published between 2024 and 2025 documenting the presence of impact markers in submerged oceanic cores and ice layers, contribute to a growing acceptance of the impact hypothesis among planetary scientists, geologists, and climatologists. These advances coincide with technological breakthroughs in detection and dating methods, increasing the resolution and reliability of data. Furthermore, improved communication and collaboration across disciplines have fostered interdisciplinary research efforts, embracing the impact hypothesis as a framework for explaining abrupt environmental and ecological changes in the late Pleistocene. Conferences such as the annual Planetary Defense Conference and publications in high-impact journals now include presentations and discussions on the Younger Dryas impact, signaling a mainstreaming of the topic previously relegated to niche debate. This evolving acceptance poses profound implications for our understanding of human history, climate science, and planetary defense. Acknowledging the Younger Dryas impact challenges the traditional view of Earth's stable environment during the last ice age and highlights the fragility and resilience of life faced with sudden catastrophes. It calls for integrating cosmic risks into archaeological and climate models and informs modern strategies in planetary defense. At the heart of this controversial journey lies a complex balance between skepticism and openness, scientific rigor tempered by the readiness to revise paradigms when evidence warrants it. The Younger Dryas impact stands as a case study in scientific evolution, a reminder that truth often lies hidden beneath layers of doubt, awaiting discovery by persistent inquiry and emerging technology. This chapter as cautionary tale also reflects deeper truths about human psychology and societal progress. Resistance to radical ideas often stems from fear of overturning established knowledge or admitting previous shortcomings. Such resistance can delay critical responses to emerging threats, whether environmental, technological, or cosmic. Learning from this history encourages fostering environments where novel ideas can be tested thoroughly and objectively without ideological bias. Ultimately, the resolution of debates surrounding the Younger Dryas impact hypothesis depends on continued research, open-mindedness, and technological innovation. As we harness new tools ranging from satellite imagery and geochemical analysis to AI-powered data integration, our ability to uncover and interpret Earth's past and prepare for potential future catastrophes fundamentally improves. Overcoming controversy enables harnessing this knowledge for practical benefit, better forecasting of future cosmic impacts, informed urban planning in vulnerable regions, and global cooperation on planetary defense initiatives. These are vital steps to ensure that the lessons encoded in ancient stone, sediment, and story do not fade into forgotten myth, but empower humanity to face the skies with awareness, preparedness, and hope. As the scientific community continues to grapple with the mysteries of our ancient past, the Younger Dryas impact hypothesis stands not merely as a question of historical curiosity, but as a linchpin in understanding the delicate balance between cosmic fate and human survival. The accumulating evidence from ocean sediments to Arctic ice cores, from shocked quartz to platinum nanoparticles, offers a powerful testament to a cataclysmic event that shaped the trajectory of life on Earth. This final chapter brings us to consider what humanity can learn from this story, not just about its distant past, but about the precarious future we face. The latest research, particularly breakthroughs in 2025, shows a synchronous layer marking the Younger Dryas boundary, found in remarkably correlated sites stretching across North America, Europe, and parts of Asia. These markers not limited to rare metals, but also including microspherules, nanodiamonds, and black carbon layers, paint a picture of an explosion in the sky that unleashed a chilling global winter. As ash and soot blocked sunlight, temperatures plunged, glaciers expanded, and ecosystems teetered on the edge of collapse. The timing aligns with the tragic extinction of megafauna, such as the woolly mammoth, saber-toothed cats, and giant sloths, and with the disappearance of the Clovis culture, a beacon of human ingenuity and survival now lost to time. While some skepticism persists, this tide of evidence is beginning to shift scientific paradigms. The impact hypothesis has withstood rigorous testing and reconsideration, with advances in analytical techniques confirming the spatial and temporal correlations across these distinct sites. It challenges us to rethink how interconnected Earth's environmental systems are with celestial events, and to appreciate how even a single astronomical encounter can ripple through every strand of life. More importantly, this history is not just about destruction, it is about resilience. From the ashes of that darkened sky, survivors inherited knowledge, adapted, innovated, and rebuilt societies. The architectural precision of Göbekli Tepe, the encodings of celestial warnings in stone, the diffusion of agricultural innovations, and the persistence of flood myths all attest to humanity's enduring spirit. These legacies serve as cultural anchors, reminding us that while history can be shattered, the human capacity for survival and understanding is unbreakable. As modern citizens of Earth, we stand on a precipice shaped by this ancient event and the cycles it initiates. The cosmic debris that once felled civilizations still travels the solar system, intersecting Earth's path on millennial rhythms. The growing capability of space agencies to detect, track, and perhaps someday deflect near-Earth objects is a testament to human ingenuity, but also a stark reminder of vulnerability. This knowledge compels us to vigilance and preparedness. A catastrophic impact today would carry consequences far beyond ancient times, threatening the stability of modern civilization with its technology-dependent infrastructure, sprawling urban centers, and interconnected global supply chains. Yet humanity has the power to learn from the past, merging scientific insight with cultural memory to forge policies and technologies aimed at cosmic defense. Finally, the message encoded by the survivors of the Younger Dryas is a call to collective responsibility, an urging to heed the lessons of history inscribed in stone and sediment, to bridge science and tradition, and to act with foresight. Their voices, as ancient as the stars, remind us, civilization as survival depends not just on reacting to disaster, but on anticipating and mitigating cosmic threats. In closing, the Younger Dryas impact is more than an episode of environmental upheaval. It is a mirror reflecting the fragile relationship between Earth and the cosmos. It is a story of ruin and rebirth, warning and wisdom, loss and perseverance. As we gaze upward, we are reminded that the sky above holds both the memory of catastrophe and the promise of renewal. The past whispers through the ages, urging us to listen, to prepare, and to cherish the delicate gift of life perched upon this small, blue planet amidst the vastness of space. Only by embracing this legacy can we hope to navigate the uncertain celestial seas ahead, protect our fragile world, and pass onward for generations. A story not of destruction alone, but of enduring hope,